brain you were taught and the brain we now know. Most of us understand the brain using ideas we learned a long time ago, at school, at university, from doctors, newspapers, magazines and television. That knowledge wasn't foolish. It was the best available at the time. But this talk is about what happens when knowledge moves on, quietly, and public understanding doesn't quite follow. This isn't a criticism of the past, it's an update. If you grew up trusting experts, that was sensible. Doctors were trained, teachers were qualified, journalists relied on specialists. You were encouraged to respect authority and evidence, and that was not a mistake. The issue is simple. Science kept advancing, but most people were never told that the story had changed. For much of the late 20th century, the brain was explained in fairly simple layers. A thinking brain at the top, an emotional brain underneath, and a primitive brain driving basic instincts. If someone struggled, the explanation was often that something wasn't working properly. A delay, a deficit, a disorder. The assumption was that there was one normal brain and everything else was a deviation. That assumption shaped how difference was understood. If a child didn't sit still, focus, or follow instructions, the problem was assumed to be within the child. If someone struggled socially or emotionally, the brain was seen as faulty or underdeveloped. The goal was usually correction. Fix the individual so they fit the system. This logic felt obvious at the time. One reason those explanations dominated is that we couldn't actually see much inside the living brain. We had EEGs, which measured electrical rhythms, early CT scans, which showed major damage, and behavioural observation, which told us what people did, not how their brains were wired. So scientists inferred structure from behaviour, carefully, thoughtfully, but with limited visibility. Around the turn of the millennium, brain science quietly shifted. Imaging technology improved enough to show the working brain in real time. Not just where activity happened, but how different regions worked together. This didn't add a few details. It changed the picture completely. The brain stopped looking like a machine with parts and started looking like a network. Modern neuroscience shows the brain as multiple systems operating together. There is no single control center. Information flows along networks. Different brains prioritize different pathways. Some brains process quickly and broadly, others slowly and deeply. Some filter sensation aggressively. Others let much more information in. These are not errors, they are trade-offs. This is where older explanations begin to fail. Autism and ADHD were originally described almost entirely by what people couldn't do. Modern neuroscience shows different connectivity patterns instead. These brains bring real challenges, yes, but also predictable strengths. The old models could only describe deficits. The newer ones explain patterns. Neurodiversity does not mean everyone is the same. It means human brains naturally vary in stable, biological ways. Some variations fit neatly into schools and workplaces designed decades ago. Others clash with those systems. That clash produces stress, failure, and misunderstanding, not broken brains. The brain you were taught about was a simplified model built with limited tools. The brain we now understand is a complex, adaptive network with many valid configurations. Neurodiversity isn't a trend or an ideology. It's what becomes visible when our tools finally catch up with reality. Nothing about believing the old story made you wrong. But now that we know more, updating the story is simply the next step.